and the relativization of the Kantian a priori.
Yeah, thanks. Thanks. Well, yeah, I came up with this idea thinking about our general topic, so structuralism, the FA, in this sense. So mathematical structuralism, because, well, one thing that interests me in connection with Cassirer is the way in which he has been recently reconsidered as a possible a resource to account for some mathematical practices, in particular the way in which Dedekind understands abstraction, and some of the aspects of a reading of Dedekind that has been advocated especially by Reck, then Yap, and others. However, this has more to do with the so-called prehistory of mathematical structure, so to say. So people in history of philosophy who recognize the possibility of saying something about the presuppositions of mathematical practice, and so doing a sort of philosophy of mathematical practice ante litteram. As for the beyond, I am connected to this debate on the relativized a priori because, well, my aim, which will be mostly negative in this sense, would be to show that in this discussion, some of Cassirer's, but also Reichenbach's, I think, arguments have been fundamentally misunderstood because the notion of mathematical practice is projected on these authors that is not theirs. And especially a way to look at mathematics. So what is the claim that is the subject of this criticism is found in several places in Cassirer, and Cassirer states it both concerning mathematical objects and concerning physical objects. There are passages, these are some of the references where you can find an example relating to numbers, where I'm going to get back later. And also he says the same about the reality of what is characterized in a space-time structure in general relativity. What does he say? He says the language of mathematics is a purely ideal and symbolic language, and so the reality which alone it can express is not that of things, but that of laws and relations. So we need to change our notion of reality to account for scientific objectivity. As I said, this has been received in the more recent literature, first of all in this reading of Dedekind, which sees in Dedekind's characterization of numerical domains a version of mathematical structures that they call logical. And it has also been appreciated in philosophy of science in connection with the view that perhaps mathematical form or structure is what we should look at when we are trying to find what remains after theory change. It is one of the aspects that may remain constant during theory change, and this is, for example, a paper by Gower where he makes a connection with structural realism based on this thesis, and a similar connection can be made starting with Cassirer or with Schlick. What is the problem? Now, understood in this way, this claim attracts criticism from those who, in this debate on the relativized a priori, try to explore the idea of a contentful a priori, or constitutive elements of different kinds. They might be mathematical, but they might also be empirical, that are understood as preconditions for scientific practice. And these people think that forerunners like Cassirer don't have the necessary conceptual tools for thinking about conceptual change or change when something deeper is going on than just relating abstract mathematical structures to each other. So what am I going to do? I wrote aims because perhaps these are aims of a larger project rather than the talk, and I'm not going to probably fulfill them in the talk. The aim would be to try and appreciate also the larger epistemological implications of Cassir's account of mathematical practice, and specifically his position in the early 20th debate on the relativized a priori, where several options were available between relativizing and rejecting reactions to the Kantian a priori after general relativity. So in particular, the way in which Cassir positions himself between Reichenbach, who rapidly changes his mind on the possibility of relativizing a priori, and Schlick, who is the one who convinces Reichenbach that it is probably best to leave the idea of relativizing a priori and replace them with a notion of convention. And my main objective is to try and see how, if Cassir's account of mathematical practice is appreciated also from this larger perspective, perhaps this may show how some room is left for a non-trivial account of conceptual change. So not just an account which would say, well, yeah, there are a prioris, but we can revise them indefinitely no matter what happens in science. We're going always to be able to find new a prioris using some kind of formal account of theory change. So in the outline I'm going to part it in the two parts. The first more related to what Cassir says about the Dedekindian abstraction and the origin of the notion of a structure. And the second on the two ways of relativizing the Kantian a priori that are found in the early 20th century, on the one hand Cassir and on the other hand the early Reichenbach. So I think that what is missing from the current way to appreciate Cassir's contribution to this discussion is an account of the theory of abstraction that starts really with the idea of looking historically at different stages where abstraction is developed in the way that is relevant to modern mathematics. This happens for Cassir in a stepwise fashion. And Cassir starts very early in this reconstruction of the theory of abstraction, so analyzing what he calls the received view that he associates with Aristotelian syllogistic. And that is the view that assumes that the content of knowledge can be given only as an individual, and so universal concepts are formed by individuation of the similar determinations in what is perceived and disregarding the rest. So what is characteristic of this view is that it has a negative account of abstraction. What abstraction does is disregarding what is not a commonality, and these commonalities they inherit to the identity of some contents that are given as individuals, which leads to the consequence that if concepts are like that, the more general the concepts, the less specific. So if I arrive to very general concepts, I will not be able to come back to the instances in a way that can differentiate one instance from the other. I will only know that I grouped together all things that are red, for example. And what is the problem with that? Cassirer thinks that the problem is a metaphysical one. So if we proceed in this way, there will be no guarantee that the commonality of any complex of objects that one may consider also include defining characteristics. Using a famous example from Lotze, one could well try to group together cherries and meat, saying that they are both red and juicy, but these are not defining characteristics. The only guarantee can be found in Aristotelian metaphysics. So the idea that in the end the commonalities among things are their ultimate causes or substances, and that what is supposed to happen in knowledge is that these commonalities and this order of things is copied in thought. So it goes together strictly with what Cassirer also calls a copy theory of knowledge. Cassirer then acknowledges a series of reforms of this received view in the 19th century. So people like Mill, Erdmann, and others who try to refine the view by shifting the focus from this metaphysical dimension to a psychological problem. How do we group together representations? But this reform falls prey to the same objection. So even in that way, we have an internal reality of mental images instead of an external reality of things. But the epistemological problem is that there is no principle of individuation is again there. So for Cassirer, there are only a few breakthroughs that begin in the late 18th century that gradually lead to a modern notion of abstraction. The first that he points to is Lambert's critique of the Wolffian logic, where Lambert says that abstraction, understood in this merely negative fashion, tends to prevent the philosopher from the possibility of deriving the special cases under the concept. And then goes on to say that this is what mathematics is actually doing. So the contraposition is between philosophical and mathematical cognition. And then another reference that is very important for Cassirer is Lotze. So it stems from this same philosophical logic in 19th century, but is important for Cassirer because Lotze made that skeptical remark about the received theory of abstraction and formulated a demand that is that a principle should be introduced when we group together things that have commonalities that replaces the particular characteristics of some aggregate of objects which are different in different species with the general characteristic that would allow to order them in series, basically. In this way, the instances would appear as particular species of the general concepts, but in a way that makes the distinction between the single instances. And now the clue to the notion of abstraction that Cassirer reads in Dedekind is that Dedekind's definition of number presents this idea in its clearest way because it shows that numbers can never be given in isolation but only in a relational system. And in this sense, Cassirer insists on the fact that they are not things but terms of relation. So now I'm going to jump into how Cassirer reads some aspects of Dedekind's procedure and try to stress the comparison with the logical structuralist reading. The first point, before that I'm going to recapitulate what Cassirer associates to the notion of structure so far. So having reconstructed how abstraction evolves from the receipt theory to Dedekind, Cassirer puts together these different steps in which we arrive at the end of a notion of structure that is perfectly compatible with a relational system in an axiomatic way. But there are some previous stages to that. So one is that one can take from Lotz's account of concept formation. So we can as well think that we start grouping together things, but the point is that the unity of the conceptual concept can thus be abstracted out of the particular elements of its extension only in the sense that it is in connection with them that we become conscious of the rule according to which they are related. Not in the sense that we construct this rule out of them through either bare summation or neglect of parts. And in this regard, he also uses this language that is taken from Lotze, that in this way the concept is free from all things like being and attains a new kind of logical being. That is the kind of language that Cassirer takes from Cassirer in the moment when fixed properties are replaced by universal rules that survey a total series of possible determination. And to get to something more familiar to the modern notion of structure, this is how Cassirer describes the structure of natural number in Dedekind sets. So what is expressed here is just this, that there is a system of ideal objects whose whole content is exhausted in their mutual relation. The essence of number is completely expressed in their positions. And the second claim, whenever a system of conditions is given that can be realized in different contents, there we can hold to the form of the system itself as an invariant, undisturbed by the difference of the contents, and develop its laws deductively. In this way, we produce a new objective form whose structure is independent of all arbitrariness, but it would be an uncritical naivete to confuse the objective which thus arises with sensuously real and effective things. And this is the passage where he incorporates the Lotzean account of logical objectivity into an understanding of structure that is very much in line with an axiomatic characterization. The point that is interesting is how there are some notions of structure that, like in the second instance, he really says Struktur, it's one of the few occurrences, but there are related notions like Gefüge, ideale Gegenstände is a key word that is interesting. There are other people that start talking about this Gefüge, which might be translated something like construct or something like that, meaning basically what is structure, but in this looser way. So how does this relate to the procedure of Dedekind? The first aspect that Cassirer points out quite clearly and is again in the focus of the reconstruction in terms of logical structuralism is the use that Dedekind has of mappings, and a non-psychologistic reading of this passage of the preface to Dedekind's paper on number, where he writes that arithmetic seems in the very basis to be grounded on an ability of the mind to relate things to things. According to several commentators, this is an indication that what he means by abstraction is a psychological notion. However, it is a passage that connects immediately with the way in which he introduces a function that allows him to define the notion of a chain. And so the mapping, here I translated the mapping Abbildung, but the word is the same, of a system understood as a law according to which to every determinate element S of A there belongs a determinate thing called the image of S that is denoted in the usual way as a function of S. So how does that change the procedure? This, for the logical structuralist reading, changes a little bit the way in which Dedekind constructs the notion of simple infinite systems, because one should think of taking this notion of a function as some sort of primitive term that is needed to define this other key notion that is the chain from a given element. And the notion, the similarity is defined in terms of what corresponds to an injective notion, so it's a one-to-one function, and simply infinite means a system where one part can be put in a one-to-one function, in a one-to-one correspondence with itself. And then Dedekind basically formulates what corresponds to modern versions of the axioms of arithmetic, but in this language that is slightly different. So the idea would be that these differences matter, at least from a philosophical point of view, in the logical notions that he presupposes, and the main part is played by this function, because the condition amounts to extract the chain from a given element thanks to the function. And they more or less correspond to the modern formulation fully, except for the fact that here this mapping plays a fundamental role. So this is the way in which the modern formulation avoids basically the notion of a chain using a set theoretical account of it as a minimal closure of the set formed with of the element under the function that is a one-to-one. What is the point that relates to Dedekind's understanding of number? It is the problem how to interpret this passage where Dedekind states that abstracting numbers from a simply infinite system structure amounts to create these new objects, or clarifies the reason why we call numbers a free creation of the human mind. And it is a quite enigmatic passage, because this is a sort of turning points where some interpreters point to the fact that this again shows a psychologistic understanding of abstraction, which goes together with other metaphorical expressions, and other interpreters trying to clarify what abstraction means, but basically the logical structuralist reading of this tries to really make sense of the fact that numbers are created as specific objects that fall under that general concept, whereas a very similar but more not committed to logical structuralist reading would say, well, this passage only makes sense if we admit that what is created is not an object but is a concept. And so in the end, Dedekind is telling us that numbers are those positions in a structure that correspond to the places that are defined by the relations established by his conditions alpha to delta. This makes perfect sense in a modern understanding of axiomatic structuralism, but it doesn't seem to be what Dedekind says. He insists on the fact that numbers are best understood, or in their primitive understanding, they are ordinal numbers, and this is because they are being abstracted from one such general concept that is the simply infinite system. So it's a slightly different reading there. And Cassirer seems to take clearly the direction of supporting the logical structuralist reading, so claiming that yes, these are objects that are specific to this kind of consideration. But on the other hand, it is also important to insist on the fact that he thinks that some of Dedekind's phrases need substantial revision, or needs to be rephrased to say clearly what the status of numbers should be. So in this passage, he's referring to this abstraction procedure, but he adds to what Dedekind says, that the things which are spoken of, is the term that Dedekind also uses, thing, are really only terms of relation, and as such can never be given in isolation, but only in ideal community with each other. And the procedure of representing, which is Abbildung understood as that ability of the mind, more generally, rather than specifically the function, has also undergone a characteristic transformation, for we no longer concerned to produce a conceptual copy of outer impression, such as shall correspond to them in some particular figure, for representing means nothing else than the intellectual coordination by which we bind otherwise totally diverse elements in a systematic unity. Is then the kind of operation that for Cassirer would allow to generalize the idea to beyond these specific examples and even to physical examples. But before turning to that, let me recapitulate what this the way in which this converges to logical structuralism. It does converge with logical structuralism up to a certain point. It agrees that that passage can be read as stating that numbers are abstracted from a structure as one particular instance, and they are completely determined by a procedure that involves considering a series which has a first member, establishing that to every member that belongs an immediate successor to which it is connected by a transitive and asymmetrical relation. And secondly, articulating the basic definitions and principles from which all arithmetical truths should follow from the properties of progressions. And finally, what both Reck and Yap point out is that this complete determination is actually achieved in the point where Dedekind shows that his structure is also categorical, and so there is a characterization up to isomorphism, which is not something that we find in Cassirer, and this is where this symmetry also reveals one problem that Cassirer has, which is starting from this account of abstraction to make it flexible enough to adapt to other cases where we don't have this characterization of two isomorphism, but we want to think about other ways in which intellectual coordination brings about some systematic unity. And what Cassirer has in mind in 1910 is really very, very broad. So the idea is that coordination, understood in these very general terms, also plays a role in what, in this Kantian language, amounts to object constitution. So he describes a system of synthesis in which object constitution takes place that has different levels and begins with the introduction of serial principles like the natural numbers, and this is the main example here, and continues with other kinds of reasoning where the connection becomes less apparent. So cases where Cassirer describes what is going on in the use of mapping as coordination of different series. Here, another example, the more pertinent one, is that is found also in Dedekind, but in the paper on continuity of and irrational numbers. So Dedekind describes how a coordination can be established up to a certain point between the points on a line and the rational numbers. And other examples for Cassirer include projective coordinates and example of this kind, but he thinks that this is also the way that one can rephrase also the use of some physical principles. Finally, he tries to identify the developments in which wide and fruitful fields appear to be accessible to mathematical determination without their objects being extensive magnitudes, from infinitesimal analysis to modern projective geometry, group theory, from atoms to energy. So this is the part where in substance and function he incorporates also some ideas from Pierre Duhem. So he takes especially energy as the key example for the idea that one can express the quality in the phenomena with a definite number and replace these numbers for the qualities in our consideration, and this would have the virtue, unlike the mechanical explanation, of keeping the quality of the phenomena untouched, because as opposed to that, the mechanical reduction of phenomena to quantities would reduce the consideration to quantitative considerations. In this account, that is very much in line with Duhem's language, he says the notion and the principle of energy is able to institute an order among the totality of phenomena, because it only expresses a pure relation of mutual dependency, because of the symbolic or ideal nature of the laws. However, this way to generalize the idea of coordination, of course, has an important break with general relativity, and this is the part where the argument becomes more difficult to follow. So part of what he's trying to do later, when he reconsiders the role of coordination, is to claim that now new elements, Riemannian geometry and general covariance, are playing this role of bringing in univocal coordination. And in particular, he interprets Einstein's phrase that GR took from space the last remnant of objectivity as indicating that the problem of determining space in itself has been replaced by a methodological question which concerns the choice of language in physics. And because it is a choice of language, the solution is appropriate because it applies to a reality which is, again, a reality of things that are relational and not a reality of substances. And the move to do this is to say that GR establishes itself an exact coordination between the symbols of geometry and the empirical manifold, but it shows that the symbols of non-Euclidean geometry are superior in doing this. And so Cassirer changes the notion of a priori of space there by identifying the a priori of space with the general concept of line element, pretty much in line with the attempt that meanwhile Weil made to reformulate the idea of a prioris of space. So it would be this general concept of the line element, and Euclidean geometry only retains a privileged status insofar as the G null there, which indicates the effect of gravitational field, in some cases can be disregarded, and in these cases it can be transformed back to the Euclidean form. So this is actually the part of the argument that has attracted the criticism, first of all by Einstein, of just changing the a priori as science changes without being able to really explain how one gets from one a priori to another. Now, before turning to Reichenbach, the part of the argument that I think received a little less attention, but probably is revealing for what matters most to Cassirer's thesis, is the way in which he characterizes this reversal. So this idea of showing now that non-Euclidean geometry is more adapted to the demands of physics rather than Euclidean geometry, which is in these passages that are a little difficult to take into consideration from a model perspective, where he seems to suggest that well, the problem of the previous account that he gave of the a priori of space is that the simplicity of Euclidean space actually makes it into a more abstract kind of space that is unfit for the representation of space-time in physics, that is a differentiated manifold. However, Cassirer insists that there remains some sort of connection between conceptual thought and a general doctrine of manifold and order, and the idea of anticipating experience. That this idea even sort of receives a surprising confirmation, because he writes, a doctrine which originally grew up from merely in the immanent progress of pure mathematical speculation in the ideal transformation of the hypothesis that lie at the basis of geometry, now serves directly as the form into which the laws of nature are worked for, is the claim. So, before coming to some concluding remarks on this, I will briefly sketch how the contrast with Reichenbach looks like, considering this notion of coordination, which is in fact also the key point for Reichenbach. In this regard, it should be considered, this is something that Padovani especially emphasizes, that Reichenbach uses this notion already in his doctoral thesis with regard to the concept of probability, and the idea of this concept playing a constitutive role is not really abandoned, even when Reichenbach later adopts Schlick's suggestion concerning the relativized a prioris. However, the contrast with Cassirer appears more clearly when we consider the theory of relativity and a priori knowledge, because Reichenbach there draws a clear distinction between what he calls mathematical coordination and physical coordination. Whereas mathematical coordination has two sides that are defined axiomatically, physical coordination is between one mathematical side that is also conceptually defined axiomatically, and a physical reality, where physical reality must be taken initially as undefined because it is defined in and through coordination. This is what he calls the constitution there. And again, the example that he makes, interestingly, is from Dedekind. So it is this very idea of introducing the defining condition for having continuity of numbers, starting from this comparison between numbers and points. A bit schematically, the idea would be to start with the observation that the same characteristic apply to the relations line to the left, right of, and being lower, higher than. And that this means that one can state the defining characteristic of this relation that hold for the points on the line on the one hand and the irrational numbers on the other. But at this point of the reasoning, Dedekind notices that there is a disanalogy there concerning the third defining characteristic. So the third states that for every element x in the system, in an ordered system, there is a partition into two infinite systems such that the partition is unique. And this holds for all elements in the system. However, this shows that if for every number that divides the system into distinct classes, there is a point in the line, not for all points there is a number that produces the division. So this allows one to clearly define where there are gaps in the system of the rationals. And the idea is that the coordination is made univocal by the introduction of these new sui generis entities, the irrational numbers, in correspondence with the gaps. So one has to formulate this fourth condition that for every cut, for every partition, there is a number which can be either rational or irrational. Now, Reichenbach pretty much describes how this reasoning goes on as a good introduction to what he means with the physical coordination. So with the physical coordination we would have a similar problem of defining one side that is undefined initially. However, then he concludes that in the mathematical cases there is no such indefinite side at all. So if we take all four conditions from 1 to 4, we have more or less the equivalent of, again, of an axiomatization where we have defined the structure that is that of an ordered continuous systems, and then we have the lines falling under the concepts or the numbers, but we don't have this problem of coordination anymore, which for Reichenbach indicates that there is a fundamental distinction there between the mathematical and the physical, and so on. I will get at this point to the two ideas of relativization. Basically, we see that Cassier's strategy, quite in line with what Weil also proposed at the time, admits the revisability of quite a lot, because one replaces Euclidean geometry with non-Euclidean one, but there remains some a priori common to all possible space-time theories when understood in a very, very general term. Whereas with Reichenbach we have a more clear statement concerning the discontinuity from one theory to another. So the idea would be really that we have two meanings of the Kantian a priori. One is necessarily true and valid for all time. The other is constituting the object, the concept of an object in the way we saw. And so the proposal is to relativize the second meaning to principles coordinating abstract mathematical structures with physical reality in a given scientific theory that can change completely from one theory to another. So the case of general relativity shows that the system of such principles, in particular with regard to the Euclidean metric, may have to be completely revised in order to solve a contradiction with scientific experience. So we have clearly a difference in the two approaches to the relativization, in the sense that yes, for Cassirer something must remain common, and it is this part of the argument where he seems to rely on Weil, whereas Reichenbach, having this account of coordination that shows how the coordinating principles change completely, also sketches how the break happens here. And well, to conclude, I would say a few things about how these arguments are received in the contemporary debate. However, I will keep the focus on the point that is problematic, I think, there. Because, well, in Reichenbach's formulation of the relativization, it is clear that what he calls at some point principles of coordination presuppose this notion of abstract mathematical structures clearly separated from the rest. Whereas what interests Cassirer, I think, especially in this passage on the reasons for the revisal from one geometry to the other, is very much more at the limit between mathematics and physics. So how do we change the mathematics in order to meet the demands of physics? Which is something that the new formulation sort of misses. However, as for the debate, as I said, in the immediate period after the appearance of this interpretation, Schlick criticized quite harshly both interpretations and objected that it is impossible to retain either one of the meanings of the a priori in the lack of a Kantian theory of experience. So there is no such thing as pure intuitions, and the rest doesn't anymore work without this. And in this exchange with Reichenbach, he finally convinces Reichenbach that what he calls constitutively relativized principles are best understood as empirical generalizations elevated to conventions. So why call them a priori after all? And in more recent years, some attempts have been made to relativize the Kantian a priori, overcoming the problems pointed out by Schlick, of course. So Friedman's assessment is that one should gain a more plausible account of how this relativized a priori work by putting together sort of Cassirer and Reichenbach. The idea would be that we use Cassirer to show that there is some continuity insofar as the laws of the former theories can be derived as approximate special cases of the new theory. I put a question mark because I think that that is the part of the account that doesn't really fit with what Cassirer is saying, given the fact that he doesn't really have and doesn't want to have a clear-cut distinction between mathematical and physical coordination. And then one should go with Reichenbach in showing where the discontinuity lies. The discontinuity concerns the principles for linking this structure to empirical reality. Even if this is in place, however, Friedman thinks that neither of the ideas of relativism a priori are sufficient for showing what is more interesting, perhaps. So there are reasons why one should go from A to B. So this would help to show how one can, in retrospect, reconstruct what was retained, what was changed. But how do we use this to account for the change as such? And there, Friedman thinks that one should look at completely different ideas and perhaps incorporate a notion of communicative rationality in Habermas' sense to account for conceptual change. Now this account has been partially reconsidered after several interpreters have pointed out an aspect that emerged also from what we saw. So the idea that perhaps both in Cassirer and Reichenbach we have a two-tier conception of the a priori. So the idea of some principles remaining fixed and some other varying. And so Reichenbach Hayes offers a more articulated picture of Cassirer's notion of a priori, considering the different combination of the elements of scientific experience. This is an outlook that he gives that I'm not going to comment in detail, but you can see how this other taxonomy accounts for the possibility of mixing constitutive and regulative ideas. However, we see here also quite clearly the partition that I mentioned between mathematical concept and the rest. So I think he sticks to the idea in this taxonomy. And as a matter of fact, even taking into consideration this two-tier conception, the objection remains, is put quite bluntly by Stamp. Cassirer's position is untenable. What we actually use in science is our current understanding of concepts, not what the concepts really are in some Platonic heaven, or what they will be at the hypothetical end of inquiry. So he doesn't like either of the proposal for relativizing a priori, but is probably closest to Reichenbach in taking them as theory-specific constitutive elements and dropping the idea that they are a priori in any sense. So also taking up Schlick's suggestion in a way. So what to make of all this? The idea, I think, is fundamentally right of pointing out a two-tier, at least some multiple level distinction of levels that are interconnected in Cassirer's account of constitution of objectivity. However, what is more difficult to conceptualize and is key to his thesis is also the idea that the levels are interconnected and they are not necessarily hierarchically structured. So sometimes the lower level can impose demands to even point to how the higher levels should evolve. So the case of non-Euclidean geometry, Riemannian geometry in GR, would show that the order of concepts cannot fix once and for all, but may be reversed to meet the demands of lower levels. And this is also, I think, what matters most to Cassier's thesis, the thesis being that science has an ability to anticipate experience, anticipate in a Kantian sense, so according to quality, by constructing it as a structural whole. So he sort of gives up even the idea that one can set up some ordinal notions and defend that they are prior to other notions. Especially this doesn't work anymore with Riemannian geometry because it is a metrical geometry. However, he insists that his view was fundamentally right in showing this the capacity of mathematics to integrate with what is required for solving the problem coming from experience. And now, what I think is might be a clue to a contribution of his account of structure is precisely the idea that this thesis, I think, relies on a more dynamical notion of structure in a way. So not so much abstract structures as we consider them normally, but this idea of serial principles making up structure, or all the kind of intermediate notions that we've seen at work in his account of how abstraction is conceptualized as mathematics evolves. The problem, which is the biggest problem, is of course that from the serial principles to modern physics, there are many steps that are difficult to reconstruct, and Cassier's reconstruction itself is not in all places as convincing sometimes. So what he means by coordination becomes sometimes more and more loose, and it is not always apparent to find the right cases. Again, I think this is also part of the reason why what he says concerning mathematical practice is barely received in these discussions, more in general philosophy of science. And with that, I will conclude. Thank you.
So we have time for questions. English or French, I think we can take both.
Yes, please, in French, it's no problem. Maybe I'll reply in English.
Francesca, est-ce que tu peux retourner à la définition d'abstraction de Cassien? Je pense que c'est la 7e diapositive. Alors, je suis sûr de bien comprendre l'abstrait. Qu'est-ce qui est abstrait selon ces définitions?
In the first.
Oui, les deux. Ce processus d'abstraction de cette comprendre chez Cassien, je suis pas sûr de bien comprendre.
Okay, well, I think these are very much related to what he takes from Lotze. And well, one way to spell it out is that actually we have two notions of abstraction that are related to each other. One is a negative one, so abstraction is just disregarding, and the other is the more relevant one, and is not a purely negative one. Is not abstracting from, but it is constructive, or it brings a positive achievement, Cassier says, because it introduces these principles of ordering. Well, the way that Lotze actually puts it is that, in fact, the first notion is a special case of the second, where no such rule can be introduced. But Lotze also suggests that, yeah, the first is basically relevant to science because in science one wants more determination, determinability, and not this to end up with universals that are empty. So the reference here is to this, I think.
Merci beaucoup pour ces exposés. Très intéressant. Surtout, on voit bien le rapport en fait, entre le structuralisme de Casseur en mathématiques et son structuralisme dans l'évolution des théories physiques. Et oui, une question que je me posais, c'est qu'il y a un aspect que vous n'avez pas tellement abordé. Est-ce que ça compte pour vous dans sa conception? C'est que il me semble que quand il décrit la transition, par exemple, de la doctrine newtonienne de l'espace et du temps, le passage ensuite à la relativité, un premier passage à la relativité restreinte, un second passage à la relativité générale, et qu'à chaque fois, il souligne le fait qu'il y a une tendance, en fait, on a confondu historiquement, par exemple chez Newton, il y a une tendance psychologisante de considérer l'espace et le temps, de les rigidifier, de les concevoir comme des substances, et qu'il a fallu d'abord se débarrasser des substances pour les traiter comme des structures, les réimaginer comme des structures, comme les fonctionnaliser, dans son terme, on va transplacer les substances par les fonctions. Et c'est à ce moment-là qu'on ouvre de nouvelles possibilités, parce qu'on peut remplacer en fait ces deux structures séparées de l'espace et le temps par une structure interconnectée. Il n'y aura plus l'espace et le temps séparément, mais il y aura les deux. Donc il y a cette chose un peu étrange, d'une certaine façon, la prise de conscience qu'on avait dans une ancienne théorie des structures plutôt que des substances va aider le passage. Donc ça pour lui c'est même une espèce de partie de heuristique. C'est cet aspect, je pense qu'il est... bon, j'ai raison de voir ça c'est assez différent parce que quand on pense ça dans le chiffre carré, bon, il y a aussi dans le changement d'une théorie à l'autre, le point quand il s'agit de structure, chiffre carré, dans des rapports vrais, chiffre carré, c'est assez différent parce que ce qu'il nous dit, c'est qu'on a une conservation des rapports vrais dans une certaine approximation. Quand on passe la théorie, elles sont appelées. Bon, le contraire, l'aspect sur lequel insiste Cassera, c'est justement le changement de structure en fait. Et qu'est-ce qui va permettre un changement de structure? De se débarrasser d'un blocage psychologique qu'on avait qui était lié à une interprétation substantialiste en fait des concepts de l'espace.
Yeah, thanks. That is indeed very important to his account of space-time. I let it a little bit out because, well, a lot of what he says there is actually consistent with what he said before. Only before he said we have to get rid of this psychological understanding of space and time and embrace a unified physics thanks to energetics. So,
but in a way, he could rightly claim, because of this kind of interpretation of time change, he could in fact, pretty legitimately claim that he had foreseen the advent of general relativity already in substantive function, because he knew what kind of general intellectual process you could prepare such a magnitude of change, in fact, in the conception of space and time. And in a way, I think it is honest, because it's true, you can find substantive function a way to justify the steps taken by Einstein later.
Yeah, I agree, but
we are too Casserian.
Yeah, I tend to agree with that very much. The thing is that, well, on geometry, it really looks like a big turn, because all the strategy of the argument in substance and function was very much inspired by this idea of having order first And because of that, he insisted a lot also on the notion of group and the classification that tended to exclude the Riemannian geometry from consideration. So on that, he really seems to now change dramatically, attracting criticism that, yeah, this structure is, okay, you might be able to say that structures can change, but other than that, the way in which they change seems to have escaped completely. Yeah, that is a part where the argument is clearly more problematic. Yeah, thanks.
And it's precisely this change of structure. I'm curious to know whether these paradigmatic changes of structure are really related to some inconsistency in experiences, as you said, and whether it is not really somehow the human mind which anticipates such kind of inconsistency of experiences, because somehow, for instance, the relativity, the equations were already there, Lorentz transformations were there, but the interpretation changed. And then when you want really to have an experience which contradicts the old interpretation with the new one, you have to look for such an experience. It's not, and the same thing is for quantum mechanics. I don't think that you can, without having any idea of quantum mechanics, find good experiences where the old, somehow old-fashioned approach to what happens at atomic level is not consistent with your experiences. So often I think that our reasoning somehow is not only guided by experiences, but also by some kind of a priori need of a consistent theory, independently of experience. And then once you have found such, you can also find experiences which somehow consolidate your point of view.
Yeah, there I think Cassira will be very much more in line with you, because also there is a whole chapter on the book of relativity where he especially points to the more conceptual approach of the theory rather than a theory motivated by experiments. In fact, yeah, the experiment confirming the theory arrives very, very much at the end. So that is definitely in line with his approach. Perhaps one term that needs a little more explanation or contextualization there is experience, because definitely depending on also the translation, but mostly experience has a more general meaning in especially Cassira's understanding. Perhaps it's something more like scientific experience, definitely not experiment. So that might be a point to emphasize. So I think what he means here, this MPD, is really not a raw fact or even an experiment. It's very far from that, but it's more like the physical experience. So the physical component of the theory. And well, the allusion is to the idea of that well, yeah, a new geometry is needed, not so much to counter some problems found in predictions, but coming from a physical idea that is Einstein's understanding of gravitation, motivating, looking for a different formalism. So I think the allusion is to that. In fact, the fact that Einstein at some point resorts to this Riemannian geometry and in part the tensorial calculus gets to be developed even later as a consequence of the role that it plays in general relativity. So it is really, you are perfectly right, not the idea that it is the experiment that compels you to change the formalism, but rather the idea that there is a co-evolution of mathematics and physics, and is not always predictable in a way that goes from the mathematics to the physical part, but sometimes it's the other way around. So physics needs the development of a mathematical theory, and they do evolve together, which is very much an idea that if you understand the matter in terms of having infinitely many possible mathematical structure on the one hand and physical reality on the other, escapes this problem. How do you account for the fact that sometimes they need to evolve together? It seems to really escape. Of course, the reply would be, well, these are historical aspects and we don't care. But for Cassirer, definitely that wouldn't be the answer, because he thought it mattered to be able to...
I think we will take one last question and then we have to stop because we also have the meeting out. I also have questions, but I think
Mais en fait,
take the last one. Sorry.
actually, like you said many things, so I don't need to ask my question anymore. It was a bit like
Can I
you know,
ask
but-
her? Yeah.
Thank you. It was about coordination. I understood from your exposé that might be one of Cassirer's specificity and originality, maybe. The fact that the a priori doesn't need to be ordinated. That is, it's not top down, but it can be a coordination between, on one hand, physical experience and mental activity, human. I was wondering if I understood well that part about Cassirer.
Yes, I think that definitely this is one point. Like we have these different levels of concepts, and coordination is sort of transversal. So indeed, the idea would be precisely, it's not purely top-down. I coordinate something more abstract to something concrete, but there are these reversals. So here it says explicitly what appeared to be closer to experience and so more concrete is now more abstract because it's simpler and space-time is complex. So this, I read it as suggesting that simple and complex as well as abstract and concrete here are relative. So you can have degrees of abstraction, and so something that is abstract can be compared to something more concrete and become concrete from another perspective. So perhaps, but I think you put it also in a way that would be perfectly
Compatible?
yes. Thanks.